So a car of mass 1.5 tons travels horizontally on a road with a driving force of 5,000 newtons and an overall resistance of 2,000 newtons. So in part A it says draw a force diagram. So in order to draw a force diagram, we need to obviously first of all appreciate that it's travelling on a horizontal road, okay, flat road. So we've got our car, okay, so we can just model it as a box. That would be absolutely fine, okay. So we need to draw all the forces in. Now, it says here it's got a driving force of 5,000 newtons. So let's just assume it's going to the right, okay, and that's absolutely fine. So it's got 5,000 newton force. It's engine, isn't it, that's creating this push, this driving force forward of 5,000. But it's got a resistance, okay. So that's opposing the motion. So we're going to have like air resistance and wind resistance and so forth. That will be 2,000 newtons. Okay. Now the other thing we need to do is to put our acceleration, okay, in. So remember it's a double centered arrow there, and we label it A. Okay, and that's important that we have that there to show the direction of motion. Okay. Now, of course, the other forces in place is, well, this car's got a weight, hasn't it? So if you remember that it's got a weight which acts downwards, okay, from its centre, and that will be the mass, if you remember from the last question. Now, it's 1.5 tons, the mass is, but a ton is 1,000 kilograms. So 1.5 tons will be 1,500 kilograms. So remember, the mass then is that, and you've got to times that by the value of gravity. Yeah, you've got to times it by g, okay, which we know is 9.8, which will give us our weight. Now, one more force we need to add in, okay, because we're not completed yet with our force diagram. There is another force. The issue is if I leave it like this, okay, it looks as though vertically this car is just going to drop, because in terms of forces, there's just a downward force, so really it should just fall. But we know in reality it's not going to fall, it's going to stay there, okay. It's not moving in the air at all. It's staying on this flat road, and of course the reason for that is because it's on the road, isn't it? The road is supporting it. So if the road wasn't supporting it, okay, it would sink, wouldn't it? It would just fall. If it was in the air, it would fall. If it was on water, it would eventually sink. Yeah. But this road is strong to keep it in place there, and it doesn't drop at all, doesn't it? It stays there. So there's an upward force, okay, balancing it. All right, and that upward force we call the reaction of the road. Okay, so we're going to label it R there. All right, it's the road reacting to this car. So the road is very strong, and it's there to make sure that nothing drops through it. And it's, in a sense, it's reacting to the weight of that car, and it's able to keep it in that position there, so it's not allowed to drop. So essentially, it's got to match its weight. So we can literally say that R, the reaction, is 1500 G. Now it's often called the normal reaction as well, okay? Because that reaction will be right angles. So the normal right angles to the point of contact there. So R will equal to 1500 G. So we are going to then draw this force diagram, which we've done, and then determine the acceleration of the car. So if I apply Newton's second law, okay, in the direction of motion. So this way is positive, yeah. So the resultant force equals mass times acceleration. So the resultant force, we've got 5,000 going that way, 2,000 opposing it, and that will equal then to the mass of the car. Now the mass is 1500, remember, times then the acceleration, which is which we want to work out. So this turns out to be then 3,000, 1500A, and then we just divide by 1500 to get our A, and that means then our A is 2 meters per second squared. Okay, they don't ask for it in this question, but if they asked us to work out the weight of the car, of course then you would work out this calculation. You would do 1500 times 9.8, yeah, and you would get the weight of the car, but they haven't asked it here. We were just interested in determining the acceleration.